Hello there. In this video, we're going to be looking at the last section of our unit on absolute values and reciprocal functions. So this one is going to be on reciprocal functions of a quadratic function. So we got two examples that we're going to be looking at. In the second example, if you want to pause and try it yourself, you're welcome to do that. So for the first one, it says, for the following functions, sketch the function and the reciprocal. Identify the zeros, asymptotes, invariant points, domain, and range. So really everything that we did in our last lesson with linear functions. So here's our function, f of x equals x squared minus 4. And remember, that's the same as just saying y equals x squared minus 4. So what I'm going to do first is find most of the information and the graph for just this function right here, and then after I'm going to do it for the reciprocal function. So let's find our zeros first. Remember, to find our zeros, you just take the function, so y equals x squared minus 4, and then change the y to be 0. So this is 0 equals x squared minus 4. Then you could add a 4 onto both sides, so you get 4 over here, just x squared here, and then take the square root of both sides to get the x by itself. This square and the square root are going to cancel, so we only have an x on the right and on the left. The square root of 4 is 2, but remember, we got to put a plus and a minus whenever we introduce that square root. So our zeros are going to be at positive 2 and also at negative 2. So I'm just going to plot those. We're going to have one at positive 2 and also one at negative 2. So next what I'm going to do is I'm actually going to graph my original function, y equals x squared minus 4. So to do that, I'm going to use my graphing calculator. So I don't mind if for like on these questions where you're graphing or on the quiz, you can use your graphing calculator to help get some points. That's totally fine. It's when we're doing these things here, where we're finding different values, that you definitely have to be doing by hand. So let's go into our y equals, and we'll put this in. So x squared minus 4, and we can click graph. So there's our graph, and then we're going to try to get some more points on this. So I'm going to click second graph to get to my table, and I'm going to plot some of these points. So at 0, it's at negative 4. That's right there. At 1, it's at negative 3. So that is right there. And at 3, it is at 5. So 3 over. We're way up at 5, and then we're going to get the same points on this side because this is a parabola and our parabolas are symmetric. So we're also going to have a point right here, and we're going to have a point right here. And then I can draw my parabola going through those points. So that would be my original function. And next what I'll do, just to get it out of the way, is I'll do my domain and my range for this. Now I can see my domain. It's going to get all of the x values. This just keeps going this way and just keeps going this way. So x will be an element of the reals. And our range, it only ever goes as low as this point. So it goes as low as negative 4, and then it comes back up. So let's just write our domain and range out down here. So our domain is x can be anything. X is an element of the reals. And our range is y, given that y has to be greater than or equal to negative 4. Next, we'll go back up and we'll start to do our asymptotes. So our asymptotes, these are going to occur where our zeros were, and also there was one where it always occurs, just like with linear. It's at y equals 0. So we're going to have x equals 2 is going to be 1. X equals negative 2 is going to be 1. That's just coming from these right here. And then we also have the 1. Every single time, you're going to have y equals 0. So again, I'm just going to write always for that one. So let's just draw those on our graph. So we've got those on in pink here now. Remember, those lines were the lines that you could never cross. So it'll get close to it, but then it's going to have to not cross it, turn, and then go upwards or downwards. Next, we're going to find our invariant points. And remember, our invariant points, these occur where the function equals a positive and a negative 1. So I'm going to take my function, it was y equals x squared minus 4, and then I'm going to solve 1 where the y changes into a 1. So that's positive 1, x squared minus 4, and then I'll do another one where it is a negative 1, and then x squared minus 4. So let's start on the left one. We'll solve that one first. So I just got to add 4 onto both sides. That'll give me 5 on this side, and then x squared just on the right. And then again, take the square root of both sides. So square root, square and square root will cancel, and this is going to be plus or minus. So we get out, I'm just going to switch sides, x equals plus or minus square root of 5. And that one went with the positive one. So I'm just going to write out the 2 points that we just got. We're going to have a positive root 5 and a positive 1. And we're also going to have with a negative square root 5 and a positive 1. Next, we'll do this one over here where we had the negative 1. So again, I'm going to add 4 to both sides, and then I'll just get 3 on this side and x squared on the right, and then take the square root of both sides. So these are going to cancel, and this is plus or minus. So we end up getting, I'm just going to switch sides, x equals positive or negative square root 3. And this one was for when the y was a negative 1. So I'm going to have square root 3 with a negative 1. And then I'm also going to have a negative square root 3 with a negative 1. So in this case, when you take the reciprocal of a quadratic, you get 1, 2, 3, 4 invariant points. So I am going to plot those on my graph here. I'm just going to zoom in a little bit. So it's going to happen wherever it's at a positive 1, so that's at those 2 points, and then also where it's at a negative 1. And then my graph is going to have to go through those points, but again, remember, it can't cross these pink lines. So it's going to get close to it, but it's not actually going to cross it. So those ones will look like that. And then on the inside, it's going to go like this. It's going to go through that, come up, and then go back down like that. Now, this point that was right here, that was at negative 4. So I'm just going to write negative 4 over here. Now, if you take the reciprocal of negative 4, what you get is 1 over negative 4, which is negative 0.25. So this point that was here, when you take the reciprocal of it, it's going to move down to negative 0.25. So it's going to go right about there. So that's another point that I have, and that's also going to help us determine the range down below later. So it can only go as high as that, and then it comes back down. So let's next draw our graph through those points. So we got our reciprocal function, and then I'm just going to make a note of these points. This one here was at 0 and negative 4. And then this one here in the middle was at 0, and then the reciprocal of negative 4 was negative 0.25. And I don't mind if you guys use the fraction or the decimal for this. So I'm going to zoom back out. And the only thing left to do is to state the domain and range for our reciprocal function, which was this blue function right here. So just for looking at the graph, we can see for domain, all the x points, I can see it goes this way and then it goes up, and we miss this x point here. So that was at negative 2, right? These are always going to help determine our domain and range for the reciprocal function. So we're not going to have a negative 2, and then we continued along, we kept going this way, and then we miss it at positive 2. So that one is also going to be missing in our domain, and then it just keeps going that way. So we'll go down here. Our domain is going to be x, given that x does not equal a positive or a negative 2, and x is an element of the real numbers. And then for our range, this one's a little tougher. So looking at the range, we're going up, okay, and then we only ever get as high as this, which is negative 0.25. So we are below negative 0.25, and then we kind of skip to here, and then it keeps going up. And this is going to get really, really close to 0, but it won't include 0. So it's basically, we'll go up, we'll skip from negative 0.25 up to here, and then it keeps going. So let's write that down below here. So it's going to be y, given that, we can put our curly bracket in front, and y is going to be less than or equal to that negative 0.25. We were below that point. And also y is going to be greater than 0. It never included 0, it's just greater than 0. And then y is an element of the real numbers. So our first example is now complete. We're going to go to our second one here, and if you want to pause the video and try to do this one on your own, you're welcome to do that. So again, we're going to first start with our zeros. So that's just taking our function here, setting it equal to 0. So it's going to be 0 equals x squared plus x minus 6. And then we'll solve this. So we can factor the right-hand side. We need a product of negative 6 and a sum of 1. So let's just write that out. Product of negative 6, sum of positive 1. And the two numbers that'll do that are a positive 3 and a negative 2. So we're going to have x plus 3 and x minus 2. And then we'll take each of those, this one, set it equal to 0, take this one, set it equal to 0, and you're going to get that x is going to equal a negative 3 and x is going to equal a positive 2. So I'm going to plot those on my graph. We're going to be here at negative 3 and then also here at positive 2. And those are also going to give us our asymptotes. So we're going to have an asymptote at x equals negative 3, an asymptote at x equals positive 2, and then again we always have this one, y equals 0. Okay, so always have y equals 0. So next we're going to graph this, so we can pull out our graphing calculator. I'm going to go into y equals, so we got to click y equals there, and then we're going to delete what we had. And then we're going to put this in. So it was x squared plus an x and then minus a 6. Then we can click graph. So there's our graph. And we want to figure out some more points. So we'll click second and then graph. And we're going to plot some more points. So at 0, it's going to be at negative 6. So that's way down here. At 1, it's at negative 4. So that is right there. At 2, it's at 0. We already had that one. That was right there. Then at 3, we are at 6. So that is all the way up here. And then I can plot the same points on the other side because I know my graph is going to be symmetric. Now this one isn't centered in the very, very middle. So that might be a little bit tougher to see where these other points are going to go. So what you can do is just look for those points on your table of values. So at negative 1, we're going to be at negative 6. So that's right there. Negative 2, we are at negative 4, so that is right here. And then at negative 3, we're at 0. We already have that point right there. And then my last one here at negative 4, we are at 6. So that is right up here. Now the one thing I don't have on my graph is I don't have this minimum value, so I'm going to find that. We can click second, trace, and then we want to find the minimum. So that's number 3. And then it asks for left bound, so go to the left, click enter. Then ask for the right, so go to the right, click enter. And then one more time for it to guess, and it'll find our minimum point, which is at negative 0.5 and negative 6.25. It's approximating, that's why it has all these other decimals here, but we can just leave it as negative 0.5. So let's plot that on here. It's going to be right about there. And then I'm just going to label that point. So it was negative 0.5 and negative 6.25. Now that I have all of those points, what I can do is I can draw my graph going through those points. So now that I have that, I'm going to move this out of the way and we are going to find our invariant points next. So that's when we set our y value equal to positive and negative 1. So remember our function, I'll just write it out here, it was x squared plus an x and then minus a 6. So I'm going to do one where it's positive 1, so a positive 1 here, x squared plus x minus 6, and then we'll do another one where it's negative 1, x squared plus x minus 6. So both of these equations are quadratic. To solve quadratics, we like to get everything on one side. So I'm going to subtract 1 here, subtract 1 here. Those are going to cancel. Then I have 0 equals x squared plus an x, and then minus 6 minus 1, that is minus 7. Now this we could try to factor. We got to try to get a product of negative 7 and a sum of 1. But it's actually not factorable. So what we're going to use instead is we're going to use our quadratic formula. So x is going to equal to minus b. So b is a 1 there, so it's going to be minus 1 plus or minus b squared. So that's 1 squared minus 4 times a. A is a 1 in front of the x squared, so times by 1, times by c, which is a negative 7. And then all of that is in our square root. And then we got to take that and divide it by 2 times a, and a is a 1. So when we simplify inside of the square root, we're going to get 29. So this is plus or minus the square root of 29, all divided by 2 times 1 is just a 2. So the point that we get out of this that's going to be invariant, it's going to be our x point, which is what we just had written. So I'll just write that out. And then that one corresponded with a positive 1. So that has to go with a positive 1. Next, we'll do the same thing for this right one. So we're going to first add a 1 onto both sides so that these 1's cancel over here. And I have 0 equals x squared plus an x, and then minus 6 plus 1, that is minus 5. And then again, we can't factor this one. We got to throw it into our quadratic formula. So it's going to be x equals minus b, which is a 1, plus or minus, and b squared, so it's 1 squared minus 4 times an a, and the a is 1, times by c, which is now a negative 5. That's all in our square root, and then being divided by 2 times a, and a is a 1. And now with this one, when you simplify the inside of the square root, we are going to get 21, so it's a square root of 21, divided by 2 times 1 is just 2. So the point that we're going to get from this, I'm just going to move everything over first. It's going to be negative 1 plus or minus 21 in a square root, all divided by 2. And then the matching point that went with that was this negative 1. So it's negative 1. So those are our 4 invariant points. There's 4 because there's a plus minus, so there's 2 here. And then there's a plus minus here, so there's 2 here. So on our graph, I'm just going to zoom in and we're going to plot our points at positive 1 and at negative 1. So that would be here, positive 1, and then here at negative 1 and negative 1. I'm also going to sketch on our asymptotes. Our asymptotes we just had here on the side. It was these 3 right here. So I'll draw those on next. So I've gotten those on. Just make sure you always use dashed lines with those. And remember with this point, that was going to be the lowest point on our original function. But then when I take the reciprocal of it, I'm just going to do that over here on the side. So it was negative 6.25. But then when we take the reciprocal of that, it's going to be 1 over negative 6.25, which is equal to negative 0.16. So this is going to be quite close to being 0. And now that I have that point, I am going to graph my reciprocal function going through my blue points and then also going through these blue points. So that is our graph of the reciprocal function. The last thing that we have to do is just state our domain and our range. So we'll do that down here at the bottom. So the domain and range of the original function for any quadratic, this is going to get all of the x values. So we can write for a domain, it's going to be x given that x is an element of the reals. And for our range, we saw from the graph, it went as low as this point, which was negative 6.25. So we can say for our range, y has to be greater than or equal to negative 6.25, which as a fraction is 25 over 4. So that's the same as negative 6.25. For the domain and range of the reciprocal function, that one's a little tougher. Remember the domain, it always comes from these asymptotes. So you can't have those points, it never cross there. So we can say for our domain, it's going to be x given that x cannot equal a 2 and x cannot equal a negative 3. And for the range, we got to look at our graph. So it is greater than 0, it's above 0, gets really close to it, but it never equals 0. And it is below this point right here, which was negative 0.16. So y has to be less than or equal to negative 0.16. So let's write that down here. We're going to have y given that, then our curly bracket, and y had to be less than or equal to negative 0.16, and also y was greater than 0, and y has to be an element of the real numbers. So that was our last example. If you tried that out on your own, hopefully you didn't do too bad. The last thing we got is our textbook questions, and they're on page 403.